Hi everyone, this is Mohan Raghavan. Today we are going to see interface in Go language. As soon as you see the topic interface, it might look like Go is a OOPS language. Nevertheless, it's not a OOPS language. But what is interface inside the Go language, and actually why do we need the interface inside the Go language? That's what we are going to see in this video. Let's jump into the video. Before starting the interface, we will understand interface actually being used inside the Go language just to avoid the repetition of code. So how are we going to avoid the repetition of code by using the interface? We will understand. In order to understand the interface, we will just have some pictorial representation here. Then we will understand the actual code so that we will implement the dry. Dry is nothing but don't repeat yourself so that we will avoid the code repetition. Already we have seen the type struct. First of all, we will create the type inside the Go language just to create our own customized type. In general, so far we have seen how to create the struct. Struct is nothing but a collection of fields that we have seen already. So let's say now we have the type struct and the method implemented hence become interface type. So first we will create the type interface. So we will come from the start. So you will create another customized type. Here it is nothing but interface. So you will have the keyword interface along with the type. Then you will be having set of method signatures. It will have the method arguments and the method return types and the method name. So these are the set of, let's say, the definitions you will be giving under the interface definition, so that whichever the type struct is implementing this method signatures, that will be considered as the type of the interface. In simple words, type interface will have the set of method signatures, and a type struct we will be having the different kinds of collection of fields. But however, if you have the methods which are defined under the interface, if you are implementing through the type struct, then it will be considered the type of interface itself. For example, let's say you can see the example here, type I interface. So here type is the keyword, I is the name of the interface, and the interface is the keyword. And we have mentioned only one method signature, which is nothing but caps M, open and close parenthesis. And then after we are creating the type struct. So here you can see the keyword type followed by the name T for the type of struct. And after that we have the keyword struct. And we have only one field inside that for simplicity, S, and it is type of string. Now you cannot see here the type T struct has implemented the interface or it has implemented the method M, right? So how will we do is, like, we will create one function M and open and close parenthesis. In last video, we have seen what is receiver function. So in simple, receiver function is nothing but who can use this function. We are totally restricting the only type of T can use this function. So that means that now this function has been tagged to the type T. So in general, now we can understand the type T has implemented the method M. So since it has matching with the interface, let's say interface method signature, it is type of T as well, or it is type of I as well. So now you can tell like this is type of T as well as type of I because it is matching the method signature of the interface as well. But here you cannot see any keyword called implements, or there is no keyword mentioning that it is the type of interface as well. So it is implicitly, it is covering the method signature so that you can directly tell this method or this type struct has implemented the interface I. Now you can see the main function. Under that we are creating one variable with small I and it is type of I. So you know that the type I is nothing but interface, but we are giving the type of T, which is nothing but the struct value. It will totally fine. Why? Because the T has implemented the method M, which has defined inside the interface. So now you can use this signature. So that means that we are implementing the T struct, but we are giving the variable name as the interface reference. So this is one line we are making something implementing interface method and linking with struct by using the receiver function. Using the receiver function T, small t followed by the type of T. So what is the advantage of this one? So why do we need to follow the interface method definition so that we are implementing the interface? It's fine. And we are giving the reference of I, that is also fine. But what is the advantage of this way? Creating the interface under the type and matching with the interface signature. So for that, we will just go to the code and we will understand where actually it implements the DRY, which is nothing but don't repeat yourself. The same kind of code snippet you can see here. So again, there is a small recap. So interface is a type, define a set of method signatures. It can be a single method, it can be the set of signatures or method, different methods as well. and interfaces are implemented implicitly. That means that we are not telling anywhere that this type struct has implemented this kind of interface. It has been implemented implicitly. So now you can see the first one, type I interface. It has only one method. M is the method name, and we are getting two type of struct. Here you can see T1 is the struct and T2 is the struct. Both has the single field, which is nothing but yes, and it is type of string. Now you can see here, I am creating one function M for linking with the T1 struct. So that means that now it is belonging to the T1 method, sorry, T1 struct, and it has implementation of M. Since it has implemented the M signature, which is matching with our interface I, so it is type of I as well. So that means that it is not only type of T1, it is type of I as well. The same time here, I am just implementing another M method, but this time this is implementation from the T2 side. So the T2 is the only receiver that can use the M method from this definition. And it is matching with along with the, let's say, the I interface. So that means that now this M method is not only belonging to the T2, it can be type of I also. So that means T2 and T1 is type of I because it has matching method implementation of M. And how can we make sure that this M method is belonging to the T1? By the receiver function, and this M method is belonging to the T2 by seeing the receiver function T2. Okay, fine. Now I'm going to create two variables which is type of I interface, but I am just giving the definition from the T1 and T2. Since we have understood T1 and T2 is not only type of T1, T2, but it's type of I also because of implementing the M method. So that we are giving the variable name as I instead of T1. Right? And after that, we are calling the method M because both T1 and T2 has the implementation of M method. So we are calling those methods. Till now, there is no confusion. Why? Because it is a separate implementation for M method from the T1 and M method from the T2, right? So here also we are repeating the code. We are not using any reusable code, right? So it is a separate implementation. But what if you have some implementation which belongs to the both type of struct? So that's where the common method comes into picture. If we have the common method and the argument type is type of I, interface type. Since T1 and T2 both belongs to the interface type I, we can use both methods, or we can use both T1 and T2 variables for this method. For example, now I1 is type of I and I2 also type of I. So it is totally possible that we can use this method for both variables. Here you can see I1, it belongs to the T1. Though it is type of I, we can use this method. The same way for the I2 as well. So now in this way, we are not repeating the code separately for the T1 and T2 because this method is common for both T1 and T2. If you don't have the interface, you need to create a separate method, two methods, which is type of, let's say VT1, and second method will be the VT2. You need to mention the different methods. Since we have the interface concept, we don't need to repeat the same method if it is a common to both type of struct. So now we can execute this code and we will understand whether it is really working or not. So here you can see it is totally working because the separate implementation from T1 and T2 also working fine because you can see the hello T1 and hello T2 and M implementation of T1 and M implementation of T2. And however, it works for the same common method for both the different variables, I1 and I2, both it works for the same common method. So that also you can see the output here. So this is all about the interface inside the Go language. So thanks for watching and have a great day.